Our subject is digital signal processing. So in this lecture we are going to discuss the properties of discrete Fourier transform. So we know that the Fourier transform is used for the conversion of time domain sequence into the frequency domain sequence. So it's a general thing. So next, from this section in this class, the students can able to understand the properties of discrete Fourier transform. So we have 10 properties. First one, linearity. Second, periodicity property. Third one, circular time shift. Fourth one, time reversal property. Next, fifth one, conjugation property. Sixth one, circular frequency shift. Seventh one, multiplication property. Eighth one, circular convolution. Ninth one, circular correlation. Last one, Parseval's relation. We will see one by one. So the linearity property. So the linear property of DFT says that the DFT of a linear weighted combination of two or more signals is equal to similar linear weighted combinations of the DFT of individual signals. So here x1 of n is the sequence. So the DFT of that sequence will be x1 of k. And x2 of n is another sequence. The DFT of that signal will be x2 of k. So this is a linear weighted combination of two signals. Its DFT, discrete Fourier transform, is equal to the linear weighted combinations of the DFT of individual signals. So here A1 and A2 are the constants. Next one, periodicity property. So here if a sequence x of n is periodic with a periodicity of n samples, then n point DFT, then its DFT x of k is also the periodicity of n samples. Sequence x of n is periodic with n samples means its DFT also periodic with n samples. So here x of n and x of k are n point DFT pair means x of n plus n equal to x of n and x of k plus n equal to x of k. So this is the periodicity property. Next one, circular time shift. So the circular time shift property says if a discrete time signal, that is x of n, is circularly shifted in time by m units, means if its DFT is multiplied by e power minus j 2 pi km by n. That means here DFT of x of n will be x of k. So here DFT of x of n minus m. That means this is the discrete time signal. It will be shifted in time by m units. Means its Fourier DFT also multiplied with e power minus j 2 pi km by n. Next one, time reversal. So the time reversal property of DFT says that reversing the endpoint sequence in time is equivalent to reversing the DFT sequence. So here DFT x of n equal to x of k. So here x of n capital N minus n equal to x of capital N minus k. Next one, conjugation. So here x of n be a complex n point discrete sequence and x star of n be its complex conjugate. Sequence means, so we know that the DFT of x of n equal to x of k. So like this, the DFT of x star of n means x star of n minus k. So next one, circular frequency shift. So the circular frequency shift property says if a discrete time signal is multiplied by e power j2 by m n by n means the DFT is circularly shifted by m units. That means this is the discrete time signal. This signal is multiplied by e power j2 pi m n by n. So its DFT will be x of k minus m. So this DFT is shifted by m. So this is the property of circular frequency shift. Next one, multiplication. So this multiplication property says that the product of two discrete sequences is equivalent to the circular convolution of the DFT of individual sequence. That will be divided by or multiplied by a factor of 1 by n. So DFT of x of n equal to x of k. So like this, the discrete Fourier transform of multiplication of two sequence x1 of n and x2 of n is equal to the convolution of the DFT of individual sequence. That will be multiplied by 1 by n. This is the DFT of convolution of two discrete time sequence. Next one, circular convolution. So this is the circular convolution of two n-point sequence x1 of n and x2 of n defined by sigma m equal to 0 to n minus 1 x1 of m into x2 of n minus m. So this is the circular convolution. Next one, circular correlation. So here this is the circular correlation of two sequence x of n and y of n. Means or xy of m equal to sigma n equal to 0 to n minus 1 x of n y star of n minus m. Next, by correlation property, we are taking the DFT of this value. The circular correlation of two sequence means we will get DFT of sigma n equal to 0 to n minus 1 x of n y star n minus m equal to x of k into y star of k. That means y conjugate of k. Next one, Parseval's relation. So Parseval relation, we know that x1 of DFT of x1 of n equal to x1 of k. Like this, DFT of x2 of n equal to x2 of k. Then by Parseval relations, sigma n equal to 0 to n minus 1 x1 of n and x2 conjugate of n equal to 1 by n sigma k equal to 0 n minus 1 x1 of k x2 conjugate of k. So this is the Parseval relation. So these are the properties of discrete Fourier transform. Thank you.